You've probably heard the term OpenClaw thrown around in AI circles, but most explanations are either too technical or completely miss the point. I've spent weeks diving deep into the research and testing different implementations myself, and what I discovered will completely change how you think about AI coordination and control. So in this video, I'm going to break down exactly what OpenClaw is, how it actually works in practice, and why it's becoming such a game changer in the AI space. By the end of this, you'll understand not just the technical mechanics, but also why this approach is solving problems that traditional AI systems simply can't handle. We'll start by looking at what OpenClaw actually means, because the name itself tells you almost nothing about what's really happening under the hood. Then we'll dive into the core mechanisms, explore some real-world applications, and talk about where this technology is headed next. Let's jump right into why this matters in the first place. The foundation of OpenClaw. Let's start with what OpenClaw actually represents, because this isn't just another AI buzzword. OpenClaw is fundamentally a coordination architecture that allows multiple AI agents to work together in ways that were previously impossible. Think of it like the difference between a group of people shouting over each other in a meeting versus a well-orchestrated team where everyone knows their role and communicates seamlessly. Traditional AI systems operate in isolation, even when they're supposed to be working together. They might share data, but they don't truly collaborate or adapt to each other's actions in real time. OpenClaw changes this by creating what researchers call a shared cognitive workspace, where different AI agents can not only see what others are doing, but actually influence and be influenced by those actions dynamically. What makes this particularly powerful is the open aspect of the name. Unlike proprietary coordination systems that lock you into specific platforms or approaches, OpenClaw is designed to work across different AI models, different companies, and different use cases. You could have a language model from one company coordinating with a computer vision system from another company, all orchestrated through this shared framework. The implications of this are staggering when you really think about it, because it means we're moving from isolated AI tools to truly collaborative AI ecosystems. The coordination mechanism. Now let's talk about how this coordination actually works, because the mechanism is both elegant and surprisingly complex. At its core, OpenClaw uses what's called a claw protocol that functions like a sophisticated handshake between different AI agents. When one agent needs to perform an action or make a decision, it doesn't just execute blindly. Instead, it broadcasts its intention through the claw protocol, essentially saying, "I'm thinking about doing this. Does anyone have input or conflicts?" Other agents in the system can then respond with their own assessments, suggestions, or even competing proposals. But here's where it gets really interesting. The system doesn't just collect these inputs and try to find a compromise. It uses a dynamic priority system that weighs different agents' expertise based on the specific context. If you're dealing with a financial calculation, the agent with economic modeling capabilities gets more weight in the decision. If you're processing an image, the computer vision agent takes the lead. This isn't predetermined either. The system learns over time which agents provide the most valuable input for different types of problems. The coordination happens in real time, often in microseconds, so to the end user it feels like working with a single, incredibly capable AI. But behind the scenes, you might have dozens of specialized agents contributing their expertise to every decision. It's like having a team of world-class experts who can instantly confer and reach consensus on any problem you throw at them. The real-world applications. Let's look at how this is actually being used in practice, because the applications are far more diverse than you might expect. One of the most compelling use cases is in autonomous systems, where multiple AI agents need to coordinate complex operations without human intervention. Imagine a smart building where energy management, security, climate control, and maintenance systems all need to work together seamlessly. Traditional approaches would have these systems operating independently, maybe sharing some data through APIs, but often working at cross purposes. With OpenClaw, these systems can actively coordinate their actions. The energy management system might communicate to the climate control that it's entering peak pricing hours, so the climate system adjusts its strategy accordingly. Meanwhile, the security system notices increased activity in certain areas and informs the lighting system to optimize for safety, while the energy system optimizes for cost. But it's not just about smart buildings. We're seeing OpenClaw implementations in financial trading, where different analytical models coordinate to make investment decisions. In healthcare, where diagnostic systems, treatment planning AI, and monitoring systems work together to provide comprehensive patient care. even in creative fields where different AI models handle writing, visual design, and strategic planning for marketing campaigns. What's particularly exciting is how this approach handles edge cases and unexpected situations. Traditional systems break down when they encounter scenarios they weren't specifically trained for. But with OpenClaw, if one agent encounters something outside its expertise, it can immediately recruit help from other agents in the network who might have relevant knowledge or capabilities. The technical breakthrough. Here's where things get really fascinating from a technical perspective, because OpenClaw solves some fundamental problems that have plagued AI coordination for years. The biggest challenge has always been what researchers call the alignment problem between different AI systems. Even when you want two AI agents to work together, they often have different objectives, different ways of processing information, and different decision-making frameworks. It's like trying to get two people who speak different languages and have different cultural backgrounds to collaborate on a complex project without any shared context. OpenClaw addresses this through what's called semantic bridging, which creates a common language and framework that different AI systems can use to communicate effectively. This isn't just about data formats or API compatibility. It's about creating shared conceptual frameworks so that when one AI talks about risk, another AI understands not just what that word means, but how it relates to the specific context and decision-making process. The breakthrough here is in the dynamic nature of this bridging. The system doesn't just translate between different AI approaches, it learns to optimize the collaboration itself. Over time, agents that work together frequently develop more efficient communication patterns and better coordination strategies. They essentially learn to be better teammates. What's particularly impressive is how the system handles conflicts between different agents. Rather than just averaging out disagreements or letting the loudest agent win, OpenClaw uses sophisticated consensus mechanisms that can weigh different perspectives based on confidence levels, historical accuracy, and contextual relevance. It's like having a mediator who not only helps resolve conflicts, but actually makes the team stronger through the process. The verdict. After diving deep into OpenClaw, I'm convinced this represents a fundamental shift in how we think about AI systems. This isn't just an incremental improvement, it's a complete reimagining of AI coordination that opens up possibilities we've only dreamed about until now. The power of OpenClaw lies not just in what it enables today, but in what it makes possible for the future. We're moving from a world of isolated AI tools to truly collaborative AI ecosystems, and that changes everything about how we can approach complex problems. What excites me most is the democratic nature of this approach. Because it's designed to work across different platforms and companies, it prevents any single organization from controlling the entire AI coordination space. That's crucial for innovation and competition. However, I do think we need to be thoughtful about implementation. The coordination capabilities are powerful, but they also create new types of dependencies and potential failure points. As more systems become interconnected through OpenClaw, we'll need robust safeguards and monitoring systems to ensure everything works as intended. The potential is enormous, but so is the responsibility to get this right. OpenClaw is still evolving rapidly, and we're probably only seeing the beginning of what's possible. If you're working with AI systems or thinking about how they might transform your industry, this is definitely something to keep on your radar. What applications can you imagine for coordinated AI systems? Let me know in the comments, and don't forget to subscribe for more deep dives into emerging AI technologies.